Hello students, welcome to second competitive lecture of S block elements. In this lecture we will discuss about calcium and its compounds. We already discussed 4 compounds in the textbook. We will discuss only additional ones in this topic. So first is ore of the calcium. So limestone or marble or chalk, gypsum, dolomite, fluorspar, phosphorite, these are the ore of calcium, and calcium phosphate is constituent of bones and teeth. So first of all, manufacturing, it is manufactured by electrolysis of the molten mixture of calcium chloride containing some calcium fluoride. Calcium chloride is obtained by byproduct of the Solvay process. Then we have compounds of calcium. So first compound, it is already mentioned in textbook, so we are moving to the other one. So next one will be calcium chloride. Fused CaCl2 is a good desiccant, that means drying agent, but it can't be used to dry alcohol or ammonia because it forms additional products with them. So this is the only addition in the topic of calcium because calcium compounds were already discussed in textbook. Now in addition to the properties of alkali metals, we can add electronegativity, electropositivity and metallic character. So these metals are highly electropositive and thereby possess low value of electronegativity. Metallic character and electropositivity increases from lithium to cesium. So electronegativity of alkali metal decreases down to the group as the trend of numerical value of electronegativity given below on Pauli scale suggests. So here is the list of the alkali metals and their electronegativity values. And as we can see, all the mentioned values can be observed, and as we move from top to bottom, these values are decreasing. And again, francium is the radioactive element, so we do not have much data about it because of its radioactivity, which is dangerous for us and very short half-life time. So we do not have much details about it. Next is a specific heat. So it decreases from lithium to cesium. Now specific heat, that means amount of heat required to increase 1 degree Celsius temperature of given substance. So here values are mentioned in calories per gram. That means calorie requirement to increase 1 degree Celsius for 1 gram of given substance. So again, as you can see, it drastically changes, and again last element is unknown for us. So lithium requires highest amount of energy to increase its 1 degree Celsius temperature, and cesium requires least, and we do not have data about francium. Oxidation potential and reduction potential were already discussed in the textbook, but still let's talk about it quickly. And you will learn about oxidation and reduction potentials in unit 3 standard 12 electrochemistry. So oxidation potential, that means tendency to oxidize, and reduction potential, that means tendency to be reduced. We are not talking about the effect on other. That means if substance is self reduced, then it is oxidizing agent, but we are talking about its reduction strength for itself and oxidation state of itself. As for example, here a reaction is mentioned. Metal increases its oxidation state by losing the electrode. So it represents metal is oxidized. Now if metal strongly oxidized, that means M plus is more stable than M itself. Ionic state of metal is more stable than the atomic state, then this compound will show higher value of oxidation potential. And if this reaction is in opposite, that means stability of M plus is less than M. So that means its reduction potential will be comparatively stronger. Now usually these metals are strong metallic in nature, that means they have strong tendency to lose electron, and by doing so they form positive ion. That's why their oxidation potential values are quite high. As we can see, lithium, sodium, potassium, rubidium, cesium, all of them shows quite high values of their oxidation potential. Now reduction potential is exactly the same with opposite sign. That means reduction potential of lithium will be minus 3.05, for sodium it is minus 2.71, for potassium it is minus 2.93, and so on. And in simple manner we can say that this is the value of electricity produced during the oxidation of the lithium. Okay, so it is contribution of lithium when it oxidizes from lithium to lithium plus. So as we discussed, all of these metals have very high value of oxidation potential, and higher the value of oxidation potential, more tendency to get oxidized, and thus more powerful its reducing nature in aqueous medium. So that means all of these metals are strong reducing agents, and that's why alkali metal liberates hydrogen, water, and HCl. So here reactions are mentioned. With water, these metal forms hydroxides by liberating hydrogen. With acids, this metal forms chlorides and liberates hydrogen. And lithium should be lowest by this trend, but it is actually opposite. Value of lithium should be lower, but it is, as we already see, quite high. And reason for that is it has maximum hydration energy, and as the reactions are mentioned. So when solid lithium mixed with water forms lithium plus aqueous solution by losing the electron, this reaction is actually the mixture of three different reactions, delta H1, delta H2, and delta H3, as we discussed in previous page. So similarly for sodium we can get same type of equation, but value of delta H for lithium is higher than the value of delta H of sodium, and therefore large negative delta H values are observed in case of lithium, and this explains for more possibility of lithium to get self oxidized, and it will behave as strong reducing agent. Now remaining points related to this unit is actually combined with P block elements. So in competitive topic, S blocks and P blocks are together. So it can be mixed with together. So some of the questions will be related to P block, some of the questions will be related to S block. So we will discuss more when we discuss P block elements. Then S blocks and P block elements will be discussed together later.